So this video is for chapter 5.2. This is part 1. Chapter 5.2, we're going to talk about future values and for an annuity and also sinking funds, and the two of them are related. So to develop this concept, we want to talk about geometric sequence. So a sequence that is geometric may look something like this. So we can have 2, 6, 18. So if I ask you to find the next two number, what do you think they will be? From 2 to 6, I could add 4, but if I add 4 from 6, I don't get 18, right? So it's not adding. If I multiply, this is 2 times 3 is 6, and 6 times 3 is 18. So that looks like it's working, right? So if I multiply 3 and multiply 3, so the next number probably multiply by 3, and then we got 54, and then multiply another 3, we got 162. So if this is my sequence, and in order to get the next term, we keep multiply the same number, they have the same ratio, then this kind of sequence is geometric sequence. So we multiply the same number again and again to get the next term. So this kind of sequence is considered as geometric sequence. So let's look at the first example. They give you a geometric sequence. They already told you this is geometric sequence. You have your first term, second term, third term, fourth terms, and they want you to find the seventh term. So there is a formula, and then we can develop how to come up with the formula, but the focus on this section is not geometric sequence, so we're not going to do that. We're just going to cover the basic. So if this is your first term, second term, third, fourth, and they want 7, right? So you need your 5th, 6th, and 7th. So let's see what is happening here. From 5 to 20, we can multiply a 4, and 20 times 4 is 80, and then times 4 again is 320. So can you go ahead and maybe grab a calculator if you cannot do it in your head and see what the next 3 number will be. So I'm gonna get my calculator, and then we have 320, need to times 4, that would be 1280 times another 4, 5120 times another 4 is going to be 20480. So this particular question asks for the 7th term. So the 7th term is going to be 20,480. So that's my answer for example number 1. All right. And the second concept they want you to look at is the sum of a geometric sequence. So this is kind of related to the main topic we're going to talk about today. So we're going to try that. What we can do is, since we have this here already, right? So let's say if I want to know the sum of the first 7th term, so we could just add them up, right? Sum of the 7th terms, we can just add 5 plus 20 plus 80 plus 320 plus 1280 plus 5120 plus 20480. So if you want to pause the video and take a minute and add them up on your calculator, see what you have. So hopefully what you get is 27305. So that's the sum, right? But they said that it's a formula you can use to find the sum of a geometric sequence. So the formula go like this. This is the sum of n term equal to a is the first term times r is the number you need to multiply to get to the next term, raised to how many terms you're doing, subtract 1 over the rate between them minus 1. Okay, so let me just explain this. So this means sum of n terms is going to be a represent the first term of your sequence. The r is the rate between each term. And of course n is like how many terms, right? Okay, so from this particular sequence, if I want to plug it to the formula, I know my first term a should be 5, and my rate, the number multiplied between them, would be 4, right? And how many terms do we have? We have 7, right? So n equal to 7. So we plug that in. I know I don't have a lot of room, sorry about that. So s of 7 terms will equal to, my first term is 5 times the rate between them is 4 raised to the 7th power, because we want to get 7 term, right? Subtracting 1 over the r is 4 minus 1, right? So let's borrow some space here, sorry about that. So here we have we can use a calculator. So I like to do it like order of operation. If you know how to plug it in one step, that's good for you. But I'm going to do 4 raised to 7 power, enter, need to subtract a 1. That's the top part, multiplied by 5. Oops, sorry. And then this is the numerator number, need to divide by, the bottom is 4 minus 1, which equal to 3, right? So that is going to give me 27305. So that matched the number we add together by hand, right? So that's how you found the sum. So the second example, they want to find the sum of the geometric sequence, and they give you the sequence here, 3, 12, 48. So using the same formula, I want you to go ahead and try and see if you can find the answer. The formula is s sum of the n term equal to the first term times the rate raised to n term minus 1. At the bottom is going to be the rate minus 1. So go ahead and plug it in and try to find the answer. You can pause the video and come back and check the answer. Okay, if you're ready, I know a is the first term, which is 3, right? And then r between them, 3 times 4, right? So 4 is r again. And then we have how many terms? N will be 6 terms. So 6 terms we want. This is the first term. 4 is the rate. 6 term is n. That's all I need, right? So basically the sum of the first 6 term equal to, the first term is 3, the rate is 4, raised to the 6th term minus 1, r is 4 again minus 1, right? So we're going to have 4 raised to 6, enter, minus 1, enter, times my 3. That's the top part. So basically the top part is like 1, 2, 2, 8, 5. 4 minus 1 is 3, so divide by 3. So the sum of the first 6 term would be 4,095. So that's my answer for this geometric sequence. The sum of the first sixth term is this. So that's the answer. So those are just the warm-up information for the main topic today, which is the annuity and the sinking fund. So for the annuity, annuity is a sequence of payments made at a equal periodic time. Is called an annuity. So a lot of people may try to save up some money in the future, like for retirement, or like you have you want to go on a vacation in 5 years, and then you want to save up, say, $5,000. So you may put aside some money each month in the bank. Hopefully you earn some interest, and then you can make some saving to work for you. It could be a down payment for your house, or down payment for a car, etc. So if the payments are made at the end of each time periods, and the frequency of payment is the same as the frequency of compounding, then this kind of annuity is called the ordinary annuity. So most of the annuity are like that. Okay, the time between payments is called the payment periods. The time from the beginning of the first payment period to the end of the last period is called the terms of the annuity. The future value of the annuity, the final sum of deposit, is defined by the sum of the compound amounts of all the payments compounded at the end of the terms. So those are some of the terminology you may want to familiar yourself with. And two of the common use of annuity are to accumulate funds for some goals or to withdraw funds from an account. So you want to save up to a big amount of money, maybe for down payments, or like at the end of saving, you may want to turn it into like a retirement account, and then you will pull money each month to live on. For example, an annuity may be used to save money for a large purchase, such as an automobile, college education, or a down payment of a home. An annuity may also provide monthly payments for retirement. So that's what we just talked about, right? So we're going to explore those options with some of the example, and I will try to give you this document so you can print it out to work on it if you want to. So let's look at some example or the formula first. So the first one, I know there's a lot of formula here. I personally will use this formula because I want to keep those letter the same every time. Some of the book, they may convert the R over N to the inches per compounding periods and have a big N here, mean how many payments or deposit you have. Those are pretty common conversion. Your book have some really crazy stuff. Your book like invent a lot of different letter. So it's the same formula, but that's how your book write. So I want to provide you with that in case you're confused. In general, the I mean the interest rate divided by how many times compounding per years, and the big N is like how many times compounding per year times how many years, which means that how many deposits or how many compounding times you're going to have. So for that, I want to explain a little bit more. So first of all, on the top part, this is for the future value of the annuity, like how much money you have in the account after all these deposits. And the second part is for sinking funds. So we did the simple interest and compound interest from the last chapter sections. So I want to clarify this just a little bit. So for chapter 5.1, we have two types that we look at. We look at the simple interest, and we look at the compound interest. So the difference between this and also what we are doing in 5.2 is both of those start with lump sums of money. So you may put in $10,000, $5,000, and use that to calculate the simple interest or compound interest. But 5.2, the annuity and sinking fund is not the same. Both of them have periodic payments or deposits. So that's kind of the different part for the simple interest, compound interest, lump sums of money, annuity, sinking funds. You have periodic payments or deposits. So an annuity is an interest-bearing account into which we make a series of periodic payments of the same size. Okay, so again, the book formula are this guy and this guy, so it's a very confusing way to put that together, so I personally don't like it as much. Okay, for this part, the I, let me write down, this is the interest rate per compounding periods. And the n here, n times t, is number of payments totally, or number, so payment could be called deposit also. Number of times compounding. Alright, so these are the information about those formula. On the next part, we have a table here. It kind of explain how the ordinary annuity growth. So over here, if you look at the table, let me zoom in just a little bit more, maybe it will help. Okay. So we started with payment each month. Either I pay in or deposit $100, and it looked like I keep doing it every month for $100, and until 360 months later. So we are paying it 360 times. This is 360 monthly payment. How many years is that going to be? So we can think of it as each year have 12 months, right? So 360 divided by 12 months a year. Is going to show me I totally did it for 30 years, right? So this is an annuity that you pay in every month for $100 for 30 years. So totally you have 360 payments, right? Alright, so as you can see, each month you put in $100, right? For the first month, you don't make any interest, right? So your account balance would be $100. And then the next month you put in another $100, so your account should have $200, right? But you make a little bit interest out of the first $100 you put in, and then you put in another 100. So if you don't have any interest, that would be 300, right? But because you are compounding the interest every month, so you earn a little bit more interest, and then your balance is a little bit more than $300, right? So you do this for 30 years. Toward the end, that's your account balance, and it looked like you make $344.92 for your interest. We can double check it, I guess. So let's think about how much money you put in totally. if each month I put in $100, and totally we have 360 payments, right? So I'm going to multiply 360 payments. So totally I'm going to put in 360 and 2 more 0, right? So I put in, so you totally put in $36,000, but it looked like at the end of the time, 30 years, you get like $83,225.86, right? So because each period, each month, you accumulate a lot of interest, and when you add them together, it's a lot of interest. So let's see if $36,000 is what you put in, and how do we find the interest? Because I don't have this whole table, I cannot just add them up, right? So the interest is going to be the future value. So this is your future value, subtracting the total payment. No, it's one L, okay. Total payment. So future value is $83,225.86, subtracting the $36,000 that we put in. So let's see. 83,225.86, subtracting my total payment. So wow, I made $47,225.86 for my interest. So that's quite powerful. If you can find 5% interest rate, which is pretty high at this moment, and then you're willing to be very disciplined, put in $100 each month for 30 years, toward the end you make more than double your money. And that's why like a lot of banks are willing to lend you money to buy a car, buy a house, because like sometimes your house loan may be 30 years and they can easily double the amount of money they lend you and make a lot of interest. Alright, so next we're going to do some examples.